Grande. She is a nutrition consultant coming from Brazil, so possibly the person who's traveled farthest to get here. Some of her accomplishments are she is a nutritionist and a food composition compiler that has contributed to the development and update of several national and international published food composition tables. She holds a PhD in applied human nutrition from the University of Sao Paulo in Brazil and is a consultant on the food composition since 2015 at the Food and Agricultural Organization of the United Nations. Welcome.
Good afternoon. First of all, I would like to thank all the organizers for the invitation and also for including food composition as a topic on this workshop, since it's an important issue that is very frequently not very discussed in this type of workshops. So I'm going to present the importance of food composition data for estimating micronutrient intake, what we know now and into the future. So we are going to talk here about the definition and importance of food composition tables and databases, what can affect food composition data, limitations and considerations for using food composition tables, the consequences of wrong food composition data, food composition tables that we have available globally, and key messages. So we saw here today that the double burden of malnutrition is characterized by the coexistence of undernutrition along with overweight and obesity, and also diet-related non-communicable diseases. And all these problems are linked to the quantity and also the quality of the food that people eat. So recognizing what is inside the food that people eat is the first step to try to overcome all these problems. So why food composition data is so important? Food composition is the basis for many activities in nutrition. So here we can see that food composition data can be used, for example, for breeding research, which will lead to agricultural programs and policies. We can also use food composition data for diet formulation, for food labeling, to estimate nutrient intakes, which will be the basis to establish the nutrient requirements, and also for research that link the nutrient intake with disease, to establish also food-based dietary guidelines and food fortification. So many activities that will result in policies and programs related to nutrition, food security, and health. Here, just to give an example about the importance of food composition data. So we had in 2016, FAO declared as the International Year of Pulses, and the purpose of the year was to promote the consumption and also production of pulses, and they collected all the benefits of pulses linked to nutrition, health, and food security. And here we can see that except for one benefit, that is long storage and low food waste, all the other benefits are somehow linked to food composition. So that's why it's important to know what is the composition of the foods. And when we want to find data about food composition, where do we look for this information? We go to food composition tables or food composition databases, since they provide detailed information on the nutrient values of foods, and they are usually expressed per 100 grams of food on the edible portion. And normally, food composition tables include data for energy, macronutrients like carbohydrate, protein, and fat, and also micronutrients like vitamins and minerals. In addition, some food composition tables also have non-nutrients. But we cannot treat food composition data like just a value, because many factors can affect the composition of one food. So for example, we can have the food description. If we take the same food, raw and cooked, we will have different composition. We can also have different component definition, different compilation and documentation methods, different recipe calculation methods. We have different values according to the quality of the analytical data itself. And we also have the genetics, meaning that different varieties or cultivars can have different composition. So many users, they do not know about this variability and they treat any food composition data equally. So it can introduce errors in its applications, which will result also in errors in programs and policies. So here I'm going to talk about some of these factors that can affect food composition data. So here I just want to give an example how a food composition table look like, but I think that most of you have already looked for data in a food composition table. So here I have the FAO in Foods Global Food Composition Database for pulses. This is the simplified database where we have the food description that should be as precise as possible. And we have here also the description of the components. And for each food, we will have the mean value for each component. But we can have a more detailed, a complete database. This is more for advanced users that want details about the data. So here we have, in addition, summary statistics with the median, minimum, maximum, standard deviation, and number of data points that we used to calculate the mean value. And we have also documentation at food and component level, giving more details about the information on the food composition table. So how we make a food composition table? And in an ideal food composition table, the values are based on the results of analysis carried out specifically for a database. Because doing it like this, we can have a national sampling plan, meaning that we are going to collect samples in the country and it will be representative of the food that the country has available. And we will also use appropriate analytical methods carried out under quality assurance processes. But what happens is that this is a very costly procedure. So normally we don't have an ideal food composition table. We always try to have the best food composition table as possible. So we also use other sources of data. We can compile data from the literature or unpublished laboratory reports. We can also borrow values from other food composition tables. We estimated values from similar foods, what we call imputed values. We can have recipe calculations, so based on the composition of each ingredient, we can estimate the amount of nutrients in a recipe. And we have also presumed data. So, for example, we don't need to analyze cholesterol in plant foods because we don't expect to find it. So we just assume this value as a 0. So we use all these approaches when we are making a food composition table. So it's a very detailed process. And also, when we are going to use this data, we need to be aware about the limitations and considerations when we are going to use this information. So here I'm going to talk about some of these limitations. So the first one is incompatibility of databases. So to exemplify, if we make a very simple question, so how much vitamin A is there in papaya? That is a simple food. So if we go and we look for this information in different food composition tables, and here I have one from the US, one from India, one from Brazil, and another one from West Africa. So we can see that I could find papaya in all food composition tables, but the components that I found that are related to the vitamin A content changes among the databases. But if we look only into these 3 first columns where we have the total vitamin A, we can see that Looking into 4 different food composition tables, we can find 3 different definitions for vitamin A, 3 different ways to calculate. And there is, for none of them, we have the information in all databases. So for example, in India, we have a detailed information on these, the components that we use to calculate total vitamin A, but we don't have the total value, making it difficult for users. And if we look at the values under each column, we can see that the numbers are quite different. So that's why it's important to know which type of data we are looking for. So here I have the most common units used to express total vitamin A. So we have retinol equivalent and retinol activity equivalent. They are calculated based on the same components, that are retinol and carotenoids. And for carotenoids, they don't have the same activity, so we have to use a conversion factor for these components. And what happens is that when we calculate retinol activity equivalent, we consider that the activity of provitamin A carotenoids is half than what was previously adopted by retinol equivalent. So we will have lower values using this unit. And what does it mean when we estimate nutrient intake using the different definitions of vitamin A? So here I have an example. So Moltedo and colleagues, they calculated the adequacy ratio for vitamin A in 5 different countries using the 2 definitions for vitamin A based on household consumption and expenditure surveys. So we can see here in blue, we have the estimations with retinol equivalent, and in purple with retinol activity equivalent. And we can see that the adequacy ratio is quite different when we use one or the other unit. And when we use retinol activity equivalent, in 3 out of the 5 countries, the adequacy ratio was below the recommended intake, so meaning that it was less than 100%. So it makes a lot of difference on the estimation of adequacy when we use one unit or the other one. So that's why it's important to be careful with this type of values. And we have many problematic components like vitamin A, either because we have different ways to calculate the total value of the component, or because we have different analytical methods that will result in different values. So we have to be very careful when we look at the information of these components in food composition tables. Another limitation is the coverage of food items. So I will talk about fortified foods here. So we know that food fortification is common in many countries, but most of food composition tables, they do not contain data for fortified products. What will result in a huge differences in the estimation of nutritional inadequacy when we consider or not these fortified foods. And I'm bringing here an example from Brazil. So we have fortification of wheat and corn flours with folic acid as mandatory in Brazil since 2002. But until a couple of years ago, we didn't have any food composition table including these fortified foods. So we decided to include folic acid content of fortified foods in the new version of the Brazilian food composition table, and this was part of my PhD work. So just to show the impact of these changes that we did in the food composition table, here I estimated the total dietary folate equivalent intake in Brazil using our national dietary survey. So for all the different regions in the country, we'll have in blue the calculations before the changes that we did in the food composition tables, and in purple, after the inclusion of fortified foods according to our regulation. And we can see that in all regions we had a higher average intake for dietary folate equivalent, and except for the region north, in all regions the intake was higher than the recommended intake for folic acid when we considered the food fortification. So showing that it's really important that countries have in their food composition tables data for mandatory and also voluntary fortification according to the practices in the country. Another limitation that is related to the limited coverage of food items is related to biodiverse foods. So here I'm bringing again examples from Brazil. We have compiled data in the past few years for many different varieties and cultivars of the same food. So here I have some foods that are commonly consumed in the country, and I put in this table the minimum amount that I found for calcium, vitamin A, and ascorbic acid, and also the maximum amount depending only on the variety or cultivar. So, for example, if we look into sweet potato, we can see that the vitamin A content can be, the range can be from 0, that it was the minimum amount that we found, to more than 3,000 micrograms of vitamin A in 100 grams of sweet potato. What does it mean? It means that if one person consumes 1 serving size for sweet potato, she will consume from 0 micrograms of vitamin A until 12-fold the recommended intake in only 1 serving. And also, we can see here, for example, for strawberry, we can see for ascorbic acid, the range from 31 to 112 milligrams per 100 grams, and also considering 1 serving size, we can have from 97% of the recommended intake until more than 300%. So it makes a big difference for some nutrients if we consume one or other variety for the same food. And when we talk about biodiversity, we don't talk only about cultivars and varieties, we also have the underutilized foods. So here I put some examples on the ascorbic acid content for commonly consumed foods in Brazil against some underutilized foods, and we can see that the content is very different between those 2 groups of fruits. For ascorbic acid. So for example, acerola has 18-fold the content of orange, and camu camu 29-fold the content of ascorbic acid of orange. So what happens when we are calculating the nutrient intake for a population or for a person, if we don't find the data for the underutilized foods, what we normally do, we choose a food that we think that is similar, the composition is similar, so we can undervalue the nutrient content of these foods, resulting in an underestimation of the nutrient intake. So this is why it's important to include not only average values for a certain food in a food composition table, but also foods that are less consumed in a country. And what are the consequences of wrong food composition data when we access the nutrient intake in a population? So most of the problems that we have in food composition tables, they are considered as random errors. And what happens when we access the nutrient intake with a food composition table, including random errors? So we have here the true intake in blue, and we can see that when we use a food composition table with random errors, it will flatten the curve, meaning that more people will be falsely estimated as having inadequate intake. So here in my example, we can see that the true level of inadequacy should be 3%, but when we use this wrong food composition table, we will have 10. So the correlations are weakened when we have this type of results, and it will result in wrongly targeted programs and policies, meaning that we will waste funds and human resources, and we will have no progress in malnutrition rates. Due to this importance, it's really recommended that food composition tables should be set at national or at least regional levels, since the nutrient content in foods vary between countries due to a lot of factors, like genetics, growing conditions, the soil, the climate, different brands, the product formulation, food policies like certification rules, processing and preparation methods, and also the type of preparations, the recipes that are consumed in a country. So if we look globally, we have that more than almost 3/4 of all countries have already published at least one food composition table. So all countries in blue here, they have published at least one food composition table. But the problem is that most of these food composition tables, they have few analytical data, also few cooked foods and recipes, few biodiverse and fortified foods, and also few processed and branded foods. And we know that the consumption of processed and branded foods is very high. It represents a great part of the food consumption in many countries, including low-income countries. And when we look at the map, we can see all the food composition tables that we have published now. And now, in green, are the food composition tables that include branded foods in their food composition tables. So meaning that they are very few. So it's it would be very recommended that countries could work closely to food industry to include more of these products in their food composition tables, increasing the quality of the information. Another problem that we have, so here I'm showing the 107 food composition tables that I could find listed in global inventories according to the last year of update. And we can see here that among all continents, we have a lot of food composition tables that are outdated, meaning that in the yellow and also red bars, that they were updated more than 10 or even more than 20 years ago. So for sure, they do not reflect the food that is consumed in the countries now. And what are the challenges when we are developing a food composition table? So just to exemplify here, I'm bringing again an example of the FAO InFood's Global Food Composition Database for pulses. It was published in 2017 and was one of the 3 legacies of the year. And it took over 2 person-years to elaborate this food composition table among all the different authors. And to produce this food composition table, we screened more than 16,000 articles looking for data on the composition of the seeds. We were looking for 23 different species of pulses, and at the end, we evaluated and compiled more than 34,000 data points to produce this food composition table. So at the end, we could have 150 food entries and 48 components. We had energy, proximates, vitamins, minerals, and also amino acids. And what were our conclusions at the end of this work? We still had many missing values, even compiling all this information from scientific articles. So we had to borrow data from other food composition tables, especially for vitamins. And even though out of the 23 species that we wanted to include in the food composition table, for 7, we could not include any information because we had very few data available. And why do we find so few vitamin data? It's because vitamin analysis is very expensive and not all laboratories have instruments and also personnel to carry out the analysis. So, and also these analyses are difficult to obtain robust results. So this is why it's not very largely available. So for example, keeping vitamin A as our example, mostly of the analysis carried out have data for retinol, also have some data on beta-carotene, but very few additionally analyze alpha-carotene and beta-cryptoxanthin. And to calculate the total vitamin A, we need all these values. And what does it mean if the vitamin contents are mostly estimated or borrowed between the food composition tables, meaning that we have very few data available? We will have high uncertainty in the correctness of the estimations of vitamin intakes and nutritional inadequacies, nutritional research outcomes, and also the levels of recommended dietary intakes, in the nutrient labels, and also in nutrition programs and policies. So we can see that food composition tables and databases are not only just a collection of values. Food composition is a science, and it requires trained professionals in different aspects, not only just to make the food composition table, but also to use it properly. And sound composition work requires experience and expertise, and we can only have high-quality food composition table by applying international standards and tools. And to try to address these issues, we have the International Network of Food Data Systems that we call InFoods. It was established with the aim to stimulate and coordinate food composition activities to improve data quality and availability globally. And among the activities of InFoods, we have the capacity development and the publication of both guidelines and regional and international food composition tables, which are available in their website free of charge. So everybody can access this information on their website. And one of the main tools for capacity development is the e-learning on food composition data. It's a course, an online course, and it's also free of charge. Everybody that wants to take it is just to go to their website and make it. And it gives a deeper knowledge on food composition data and in principles and processes. So I really encourage everybody that uses food composition data to go there and to make it, to be sure that you will use the food composition data in a correct way. So going back to the slide where I presented that we had a lot of food composition tables that are outdated, let's look now into the good side of this graphic. So we also have food composition tables that were published or updated more recently. So we can see here in the blue bars and blue and green bars that we have many activities ongoing on the past few years. And we have about 30 food composition tables that were published or updated in the last 5 years. So countries are aware, some countries are trying to improve the quality of the food composition data available. So we can have a very good example from India. So here we had published in 2017 the National Institute of Nutrition under the coordination of Dr. Langva published a very good national food composition table for India, and it's based only in analytical data from Indian foods. So it's a high quality food composition table in terms of the availability of new analytical data, and it includes a huge amount of different compounds, components, so you can find a lot of very good information there. I know that the work is still ongoing because they are going to include more data on biodiverse foods and also on recipes and processed foods, because they are still missing in the food composition table, but it's a very good example of success in food composition, and we hope that more countries in the future will also be able to have a food composition table with a lot of analytical and new data. So the key message that I want to share with you were that food composition tables are fundamental for many activities related to nutrition, that low quality data or incorrect use of food composition tables may introduce errors in the intake assessment, resulting in under or overestimated intake for a certain nutrient, that wrong conclusions about the nutrient intake may lead to inappropriate or inefficient nutrition and health-related policies to improve nutritional status of individuals and populations, and that there is still need to generate and disseminate up-to-date and high-quality food composition tables. I would like to acknowledge Dr. Elizabeth Wenzel de Menezes. She was my supervisor during my post-graduation, and she has a very important work in Brazil on our national food composition table. And also to Dr. Ruth Sharonger. She is the InFoods coordinator and is with whom I have been working for the past few years. And thank you very much for your attention.
Thank you for that presentation. I think for a room that is mostly non-nutritionists, I think that was a very accessible presentation on a complex topic. So open to questions.
Yeah. Comment, just thank you so much for that. And for those in the room involved, say, with nutrition trials, you know, look at how many trials come out where they haven't seriously analyzed the composition of what they've been giving. And it's kind of, you know, for a health person, you might feel like, it's another thing, and you're just telling me it varies so much, and what's the problem with it? But it's true. I mean, if we tried to say, well, how strong is a human? Well, you know, I think most people would recognize there's a huge variation in that. And most of that variation doesn't have to do with your genetics. It has to do with your environment. And the same thing with these foods. Most of the edible elements of you know, foods are parts of the plant that are not highly regulated for their composition. They may be a storage tuber, or they may be usually a seed or of the plant. So just a certain... I just want to reinforce that I think your message is very, very important as we move ahead.
Thank you very much.
Thank you for a nice presentation. So this is actually a very new area for all pediatricians. But I want to know that the study which is made in this National Institute Hyderabad, whether they have taken this all kind of complex foods into account or specific foods, because you know the India being a very diverse country, having lot of foods in everywhere. Even in one village there is a lot of type of foods. So what type of foods they have taken throughout India, or they taking into there only in this south perspective of India? I want to know that, and how it is helpful to globally, because the foods are different in different areas.
I don't know if I understood.
No, what he is
You want
asking.
me to help you?
he's asking that in India there are different, the same food can have a different preparation in different regions. And the question, what is only about South Indian food or the different types we're taking in consideration?
I don't know, I can't give you a lot of details on how they did this sampling plan for the Indian food composition table, but what I can say is that for the moment they have only raw foods in their food composition table, so you don't have any recipe, any cooked food, you have only raw food. So I know that they were collecting data on recipes, but I can't give a lot of details on how they are doing it.
Okay, thank you. But one question, one more question is that being this type of foods and this composition of food you have mentioned is that it's a very costly process, right? So if somebody want to make a study on this, so how the system, or is there anything they can support for study in various regions of India or globally? So is there any organization or system is there to help somebody that they will also go for this type of studies?
In India, there are certain national institutes like NIN in Hyderabad and certain institutes in Delhi where you can get a government fund for all these things. So it again becomes a private partner or public. You have to, if you're attached with any institute, you have to approach them, and then they are willing to do a collaborative study, then that's the only option. Otherwise, individually, it's really difficult. It's really difficult. I think he was asking a question. I think let him ask, yeah.
All right, thank you for a very interesting, but at the same time, very, very important gap in the nutrition you have highlighted. My question is, you have already raised the problem that without standardized data, you cannot make recommendations, obviously, and whatever you're making today may be invalid or maybe misconceptions for the future for any recommendations. And you have already made a suggestion about having in food, I mean your collaboration. Is it actually open for across the globe to make this kind of support if any country wants to make the standardized tables, or is there anything actually actively doing on this process?
So in their website, you can find, we have the training, we have the study guide that will give a lot of examples and what we should, how we should set up a food composition table program, because countries should have a program, because food composition, when we are making a food composition table, it's a work that it's never finished, because we have many different foods to include, and it also changes during time. So InFoods have published a lot of guidelines that are available free of charge, so you can just access their website and you will find a lot of information and a lot of materials there. And also they have some global food composition databases, because they collected a lot of information, especially on biodiverse foods, and you can also access, if you have a data gap in your country, you can go there and try to find if you have the information already available there.
Thank you.
So,
Hello, thank you. I'm Dr. Shuchishmita from Kolkata. Thank you very much for a very important and wonderful presentation, because we have children, particularly parents, coming to us, advising us on health drinks. So very often the child is full of energy, bubbling and almost destroying your clinic, and yet the parents want an energy drink. So very often we tell them that maybe your child is deficit in protein, why you want to pump in energy? So helping you, we need to train them, they are educated mothers, to roll the pack and see what your child needs. And also it is helpful for children who are afflicted by certain diseases, like thalassemia, like we get a lot of thalassemia in this region, and also sickle cell anemia in Orissa. So where we can see which food has less of iron, or in children are having renal problems. So thank you very much once again for your detailed information. Thank you.
I have a small input. I think you were asking about some nutritional guideline, which most of the clinicians feels, though we don't have time to give that, but we need. See, I had visited once NIN, And they have lot of data on Indian guidelines, and they have lot of data. They have done their own research. Unfortunately, it doesn't come to the clinicians at large. So someone has to, again, I go back to the same thing, because some nutritional company like Nestle, if they can do some collaborative work with them, just the data which they have, those are all published data. They have their own booklets. So I carried a lot of booklets and I brought it to my institute, but we don't have it at large. And none of in our regular conferences, IIP and all, so they don't participate in that way. So we don't get, neither they get access to us, neither we get access. But data are there, that is important. So how we can get the data and we can use in our regular day-to-day practice, because this is an important information. We are not aware because somehow the data is lacking in our clinics level. It is there in India, it is there. That's the only thing which has to come in the public market.
Ma'am, for that, I think every food has to be labeled. I mean, there should be the standards for it.
They have done a very detailed, they have, I mean, I don't know if it's, they have done a very detailed study on many drugs, many items, food items I say. And they have different schedule for different diseases also. And it's quite a good thing, but I don't know the access why it is not there, yeah.
Is it on this point, Usha? Yeah.
Yeah, Dr. Usha.
Yeah, I think we have two issues here, and this is global, is we're having consumers who are more educated, who want to find out about nutrition, but guiding them to the right sources is important. So I agree with you that having nutrition labeling, but not anybody labeling, but that needs to be, there's got to be oversight on what goes on it. The piece which is, and Fernanda, this is more a question for you. I like your comments saying this is an unfinished agenda, because foods will change, conditions under which foods are grown, where we get our food from, we're living in a global market, etc. There's a constant change. So the big question has always been, and I'm really glad at least FAO stepped up with, at least in foods, which didn't exist even 5-10 years ago. Whose responsibility is it? Because this is a joint responsibility. There has to be commitment on guarding resources to maintain the food composition databases. So I can reflect, so in the US, it's really the industry that provides the information, and the, the FDA or whatever does, or USDA does the random sampling to validate, okay, is this information? But the US government by no means does all the analysis. They get it from the producers. And I know in India years ago, this was the role of agricultural institutes. We have CFTRI. I think it's really important to bring in all the players, and it's a joint responsibility. So
Yeah,
any thoughts? And
I think you're right, I agree. It's a joint responsibility, but I think that each country also have to recognize the need of this data and also have to run their own food composition program. Because in the US, they have a food composition program since many years ago, so that's why they have a lot of data available. Of course, they have, I don't know how many foods they have now, probably more than 7,000 foods in their food composition table, and it's not only analytical data. So what countries that have a food composition program do, they update and they produce new data on the foods that are the most important for the consumption for their population. So this is why each country should have their own food composition table, because the consumption habits, they change from country to country. So it needs, even inside one country, like it was said, even in India or in Brazil, we have different consumption habits between the different regions. So it's really a task for each country to run a food composition program and having their good quality food composition table also.
Yeah, Dr. Ganapathy, yeah.
Sorry, thank you, Fernanda. That was something that was terrific. You opened up a Pandora's box, and I'm scared that most of the research that I've gone through is flawed research. Now, we have so much of vitamin D making all the inroads in the market. You showed us only data on vitamin A. Anything on vitamin D?
Vitamin D, we have very few data on vitamin D. We tried to include it in our food composition table in Brazil some years ago, but we couldn't find any data. And I know that in many food composition tables, especially for plant foods, we assume that vitamin D is 0, and we know that it might not be correct. So we have new data here from India that was analyzed, and we could see in some foods a high amount of vitamin D, plant foods. So I think that we still need a lot of research on, especially on vitamin D, to know, to establish better values in our food composition tables.
It's the 21st century, and no, this is not an answer to everything, but there are some new technologies that are going to help this a lot if they're not done already. I work with the Global Food Omics Center in San Diego. I don't work there, but I use their resources all the time. They do untargeted metabolomics, and a sample is about $18 for a food, and it's will give you 1,600 metabolites, and many of them are these vitamins and the stuff that will show up in these tables, and the database is growing quite a bit. So I see that integrating, it's a public open source project, so it's not really run by anybody's government, but the people who do it are highly committed to accuracy and integrity and transparency. So these kind of resources also can be used and integrated into this, you know, it's not going to be in response to what you said, Usha. It's not going to be sort of organized from above, probably, because nobody's got the resources. The UN is not in a position where they're just going to take control and do all this. Companies have their own interests too. So, but I think that this is not an intractable problem.
Here in the second row and then the first row.
While we are talking so much about the good effects of all the food products and the food composition having various vitamins and minerals, are there any studies that depict the role, I mean the use of the pesticides and the insecticides that are being used in such a large extent in the growth of vegetables and fruits? An apple a day kept the doctor away for a long time, but today it's scaring to tell somebody to have an apple. The wax, the pesticide and the coating that it has, it's really scaring nowadays. So are there any studies? I would like you to tell us something about it.
I'm sure that probably we can find something in the literature, but I don't have this information to
Sporadic
give you.
studies in India are there. Like they even did a pesticide study in breast milk and found pesticides in breast milk. So there is no large data to give a guideline, but sporadic studies are being done on the various pesticides on the year. So that's a different chapter which we are not very aware of that, but studies are there.
Madam, vitamin A has known teratogenicity effect. So will you recommend to restrict the vitamin A containing food during pregnancy? Because in Western country,
restriction of vitamin A contained food during pregnancy, if it's too much there due to teratogenic effect.
I don't know.
Go ahead, Andrew.
I can't answer.
Dr. Usha wants
Okay.
Yeah.
I think Andrew.
I think Dr. Usha wants to say. Okay.
Can let me make a first attempt?
Yeah, sure.
My understanding of this is that the initial evidence all came from animal studies with high-dose vitamin A, and that even if you look, that's history, and people do really not believe that except in possible extreme circumstances, that the same will hold in humans. So if you look at the UK government website and so forth, the NHS advisories and things, none of them make a similar point now.
Did you want to add?
I basically feel what he's trying to say is the vitamin A, the retinoids. The retinoids became famous because they were used in acne and they caused a lot of teratogenic effects, especially cardiac effects. And it's proven, okay, and there is a mechanism, okay, and that is periconceptional. It's not even No, it's been there and it remains in the body, it's stored in the fat, and that's how vitamin K came into the market. Here, I think we are talking more about beta carotenes rather than vitamin A as a molecule. Fine, and I don't think it has got a teratogenic effect.
Dr. Usha?
Yeah, absolutely right. So the teratogenic effects of vitamin A is related to retinoic acid. That's not the form that's in food. It's retinol, and typically it's retinoyl esters. So in fact, it's absolutely, I mean, food-based sources and even large intervention trials that used a low dose, the kind you have in a multivitamin, is absolutely safe. In fact, we've done studies, large trials where they gave it. So it's really the form. So it's not from a food source, but the retinoic acid is what's there in acne treatment, and that is something which is a concern for teratogenic effects. But that's not what you eat, it's what you put on your face.
Higher dose of vitamin D has been fixed by the obstetrician. That is, we cannot go beyond 10,000 units in pregnancy to prevent the teratogenic effect also. And retinoic acid is a precursor of vitamin A. So it is very natural that both have gone the effect. And high vitamin A containing food can also have got the same effect.
Can I suggest you continue the conversation perhaps at coffee break? Is there any final question? Because if there isn't, I would like to ask one. I've read at least one paper that talks about climate change and nutrient composition of food. What do you know, and what can you tell us about how worried are we about the effects of variability in climate? I did notice that you had it up there as one of those predictors. What do we know about that?
I think that the climate change probably makes the producers, the agricultural practice, change the cultivars that they are growing, because normally they select the cultivars or varieties according to the yield. So as I presented here, different cultivars can have very different composition for certain nutrients. So in this way, I think it could really, really change the composition of the food that we are eating now due to climate change. We have already many discussions saying that the nutrient content on foods is reducing over time, but it's something very difficult to prove, because when we compare the analytical methods that we had to analyze especially vitamins and minerals like 30 or 40 years ago, they were not so good as the ones that we have now, so we cannot compare these values. That's why it's so difficult to come to this conclusion about the changes on the nutrient content of foods.
But one example you gave about the papaya in USA and papaya in India, 240 was the beta-carotene level of USA and 640 was in India. That is the only thing I saw, because we are so fond of papaya. So I think that comes from the climate.
Many factors affect the composition of carotenoids in foods. And for example, the amount of sunlight that we have on the fruit or on the vegetable will impact a lot the content. So this might be one of the reasons.
Yeah.
Good. I think we have a coffee break now. Thank you very much.
Thank you.